Hello? Okay, let's get started. Thank you for coming to this session. So today, Shuo and I will talk about how to leverage data science for game growth and matchmaking algorithm. A little bit about ourselves. So my name is Zhenyu, and my colleague Shuo, we are from the Tencent Games. And Tencent Games have offices in multiple locations around the world, and we are in the North America team. Okay, so in this talk, we'll first introduce the scope of game data science, and then we are going to focus on 3 areas: how to use experimentation or A/B testing for optimal game design, how to leverage machine learning for providing personalized offering, and then Shuo will give us a deep dive into how to design a good matchmaking algorithm to create a balanced and enjoyable environment for game. Before introducing game data science, I want to give a little bit background on what games we are talking about. Tencent Games publishes a lot of games around the world, and the Level Infinite is an international publishing brand owned by Tencent Games. And we publish different genres of games, and those games are developed by both Tencent studio groups and also global studio partners. Those games can be found on mobile, PC, and console. And here are some example titles on the right. We can see there are PUBG Mobile, Tower of Fantasy, V-Rising, and so on. And data science can be used for video games in many areas. And for data science technology, some technology behind those use cases are quite generic, which can be commonly seen in other industries or companies as well. And some of those technologies can be quite game-specific. For example, for marketing, CRM, LiveOps, when we talk about user segmentation, as attribution, that can be quite generic. But when we talk about how to design decision science for publishing strategy, how to do in-game fraud detection, how to develop a good game economy and social system, and how to run in-game monetization system, then that will be more game-specific. And on the right-hand side, when we talk about game design and matchmaking, we need to put more game logic into our data science solution to make an optimal algorithm in the end. And to give a more concrete feeling on what we are actually working on, we can take the perspective of a player. As a beginning, we can help to do a good ads targeting and evaluation to make sure we are reach out to the proper audience. And once the user become our player, we can use experiments or A/B testing to improve our onboarding experience for users. And we can also have generative AI chatbot to help player to know how to master the game. And we can use machine learning to provide personalized offering to the player to purchase a certain item to get them equipped for the game. And definitely we can match players to other appropriate opponents or teammates to enjoy the game together. Social is a key factor in game, so we'll have a social recommender system to help players to find friends and build friendship. And besides social ecosystem, we'll also have economy system, just like a real world. We have a currency, we have transactions, and we will put monitoring system in place to make sure everything is going on well. Otherwise, we may need to intervene the in-game system to balance it again. Once the player has a signal of churning, we want to know early. And that's where the churn model comes into place, so we can design churn intervention in time. And if a player indeed churned, then we can have a re-engagement CRM campaign, and where the data science can help us to personalize the message and also run experiment to evaluate whether this campaign indeed works. Okay, so throughout the journey, we have so many data science solutions, and we find the Databricks super helpful because of many perspectives. For example, Databricks creates a unified end-to-end data science and machine learning work stream. It's seamless, and also it has a scalable architecture because it integrated with the cloud. And it creates a collaborative working environment because different team members can work on the same workspace, same notebook, And as a centralized data team, we find it super helpful to use Databricks to collaborate with our studio partners. Because Databricks can be a very common data platform, every studio can use commonly. So that's really create a kind of a good partnership to work on the same tool. In the end, Databricks is also very flexible because it can be integrated with our internal data storage, our BI platform, and our advertising platform, as well as our game system. Because for many places, we need to have an entire architecture to make sure the data science solution is working, and we need to integrate multiple tools together. And Databricks is very easy to integrate with other tools to form an entire complete architecture. OK, now let's get into some specific areas with some examples to talk about how we use different technologies to help game grow, to improve our user experience. The first example will be how we use experimentation to optimize game design. First, let's think about for a game. It's actually a virtual world. Different games create different worlds. And those virtual worlds can be configurable through settings. Below are some screenshots of the game. We can see you can change the settings for a game. And once we change the setting, it will change how the world is laid out to you, and also change the way you interact with this whole world. So that's very important, especially for new players. They can be very sensitive. And the question is, which default setting is optimal? So to be specific, which default setting can be better for our new players? Here is one concrete example. Imagine for a shooting game. We can either display the game as a first-person perspective, or we can display it as a third-person perspective. And for business, we want to know which one is better for new players. So we can run A/B testing to make this decision. We will split new players into two groups. The control group users will see the default first-person perspective, and then the treatment group user will see the default TPP. And in the setting page, there will be a toggle. Players can always switch FPP and TPP by themselves, but they need to get into the setting page. After running this experiment, we found out actually on the overall outcome, there's no big difference between these two groups. However, we do see one interesting phenomenon. Some of the control users, they will proactively switch from FPP to TPP, and vice versa. Some treatment users switch to FPP. That means actually users have different tastes, and the result may cancel out if we compare these two treatment conditions. So that inspired us to make another iteration to make the experience better. So we ran a second round of experiments with adding one more treatment condition. In this case, we will ask the player to choose their own mode before entering the game. So now we have 3 experiment groups. And after running this round of experiment, actually the treatment 2 is a winner. So which means if we ask players to choose their own mode before entering the game, actually it increases their retention and engagement. So this story tells us multiple lessons. So first of all, players can be sensitive to the game design, especially for new players. And the experiments can be a really good decision to us. And besides, it can also give us some learning opportunity, something we didn't know before running experiment, and now we can find a better iteration. If you ask me, OK, let's say this experiment, it shows us we should ask a user to pick their own setting before entering the game. Is that a good idea to let them to pick up every setting before entering the game? Probably no, because we have so many settings. But if you feel like some settings can be really important, you cannot decide whether we should ask the player to pick their own or just set a default. We can always run experiments. That's where experiment can come into place. However, running experiments in games are not always easy. Sometimes we run into challenges. So for example, for a game-specific challenge, we will have the interference problem. So interference problem means if we have a team match game, and we match control users and treatment users together, they are going to compete with each other. And if they have different treatment effects, they are equipped with different weapons or different skills, then we are going to cause an unbalanced and unfair gameplay, and which also lead to biased experiment results. How to overcome this problem? We have multiple solutions. We can either do a matchmaking isolation, which means for treatment and control, we will match those users within their group, so they will never meet each other. However, players, especially social players, will invite their friends to join their teams proactively. So this will break our matchmaking algorithm for the randomization. So this does not work. To solve this limitation, we can run geo-based randomization, which means we can split countries into treatment and control. Then this will reduce the invitation between friends across country. However, the drawback of this solution is that it also introduce some geo-based bias because we are no longer purely randomized users. We are actually randomized by country, and users from a different country may have inherent difference in terms of the engagement metrics. So we need to adjust the bias before running any standard experimental analysis. And sometimes we can even not run any experiment because if there's a feature so good, we want to make it public to all the users fairly, then we just launch it. But we can still run offline observational causal inference to predict what could happen if we didn't launch this feature, and then we can estimate the impact of this feature launch. In practice, we will choose the appropriate method based on the business need, limitation, and also our consideration of the accuracy and the probability, the capability for running an experiment. So when we talk about those type of advanced experimentation methods, sometimes those methods are not available on our internal experimentation platform. So that's where Databricks can be super helpful. So we treat Databricks as a experimentation lab for our experimentation. Because once we have some new method want to test it out, we can first run this offline analysis to test whether this method actually works, in this case, by using Databricks. And once the prototype turns out to be successful, we feel, OK, this is the method we are going to use in the future. Then we can migrate to the experimentation platform to productionize it. So in this case, experimentation platform together with Databricks, they form a whole experimentation solution for our team. Next, I want to switch gear to talk about how we use machine learning for personalized offering. If you play video games, sometimes you can see a limited time offer pop up to say, hey, you have 24 hours to purchase the following items with a big discount. The question is how we make sure we are recommending the right item to the right player at the right time. For example, if you want to recommend the first rare ball to a player, we better find out whether this player is playing an archer or playing a mage. If we want to recommend a specific resource to a player, then we want to know whether this player at his or her current level needs this type of resource, or maybe this player already got redundant this type of resource. To solve this problem, we can use machine learning and recommender system. This architecture can be quite similar to the general machine learning or recommender system architecture. But a couple of things I want to point out here is that for in-game recommendation, it's very important to consider our players' in-game feature. Because players come to the game the main goal is not to purchase something, but they came from a game, and then after the purchase, they will go back to a game. So we want to make sure this player is actually enjoying the game. And by purchasing a certain item, they can enjoy the game more or feel proud of something. So that's why we need to consider a player feature. And sometimes the goal is not to increase monetization because the item we sold, they may not be sold on the hard currency, the real money. Sometimes we just sold on the gold coins, which can be generated within a game. So that's very important for us to consider the player's feature, in-game preference, behavior, and how we can keep the players more engaged with the game. And sometimes it's also beneficial to consider the social features, what the friends of this player obsess or purchased in the past, in addition to the kind of the regular transaction history of this player, of his or her own. And this model can be served as online serving through REST API or scheduled as a batch job through Airflow. And in this architecture, Databricks plays a central role as our machine learning training platform and the deploying platform. And using Databricks for machine learning, we really like some details, got really positive feedback from our team, talking about it creates a very user-friendly notebook-style user interface. It also has widgets for controlling the parameters in a model. And also it can be connected with a local IDE with enriched development features. And in the end, it can, when we launch a model, when we iterate the model, we can keep these records in the model registry to make the model management very easy. Next, I want to give it to my colleague Shuo to talk about the matchmaking system.
All right, can you hear me? Thanks, Zhenyu. I'll take you from here. So we're going to talk about matchmaking system, and I believe Zhenyu already mentions a little bit about matchmaking system. But before we start, can we have a show of hand, like how many people are familiar or at least heard of the concept of matchmaking system in the context of online games? Still? Yeah, online games. Okay. Actually, yeah. So that's what I thought. Like when I usually talk to my non-gaming friends, when I talk about matchmaking system, they probably think about something used in the online dating app, right? But for our context, when we talk about online like matchmaking system in online multiplayer video games, we mean something like this. This is one of Tencent's mobile game called Arena of Valor. And when you actually download the games, you want to play the game, you're gonna click this button, says start ranked match, right? And if this is a single player game, you click the button, the game is just gonna load, and then you're just gonna play the game, right? But it's a multiplayer game. When you click the button, you actually enter a queue where there's a lot of players in there waiting to be assigned to game, to be matched up, to play against each other, right? So, and then all the players need to go through a matchmaking system to actually make the match, make the game. So you may ask, why don't we just like do something very simple, just let them play, like randomly pick some player, let them play, or just whoever comes first, join the earliest, we just let them play, right? What could possibly go wrong, right? Yeah, like something like this could happen, right? So yeah, this is something we just really don't want to see, right? Like some inexperienced player, especially new player, just gonna be pitted against some players really experienced, very good player, then he's probably gonna lose. And then if this happens multiple times, he's probably gonna think, okay, this game is not for me, it's too hard, I'm gonna churn, which is not what we want to see. So what we really want is, most of the time we want this, right? Okay, so that's basically the idea of matchmaking system, right? So even though there are usually multiple goals a matchmaking system trying to achieve, but usually the fundamental goal is trying to create a balance of fair match for both sides of the game. So if there's also a lot of components for a matchmaking system. I'm just listing like two major ones. And the first one, player pool management. Basically, when you queue for the game, like you're going to connect to the server, and then just waiting in the queue, and we need to some like software, some code, like manage the server, manage the player. You're probably going to divide the players based on their like latency, based on ping, based on their region, their rank, and that's the player pool management. Once you're in the pool, we're going to run matchmaking algorithm, trying to create the basically create the fair match, which usually the goal is to balancing the players and teams, and also there are some secondary goals, like we try to adjustments for some match quality, some enjoyment for both teams. And coupled with matchmaking algorithm, we also need a skill rating system. This is coupled because the skill rating system usually involves like doing some pre-game prediction, right? So we want to see like if we pit this player against the other player, what's the win rate between the two is going to be. And using that predictive win rate, it can help balancing the player and team. And after the game happened, we observe the actually outcome of the game. One player beats the other player. Based on that fact, we're also going to adjust each player's sort of like rating. Like if you win, your rating is probably going to go up, and if you lose, your rating is probably going to go down. Something like that. And then those updated ratings is going to be later applied for the future games, like pre-game prediction. I'm going to go into the details of that in a bit. So, I forgot. So for our data science team, I would say for these three major components, data science doesn't really involve a lot in the player pool management. It's mostly like server engineering, network engineering. But we are heavily involved in a lot of matchmaking algorithm design, and also the skill rating system simulation, and basically design choices, right? So today I'm going to just share a little bit about one project we did particularly for like optimizing for choosing the right skill rating system. So when we talk about skill rating system, there are actually some choices in the kind of openly available space where one of the probably the most common one is ELO, which was invented in the 1950s by a professor named ELO, who was also a chess player. And he invented this for chess, and chess is still like using that. So nowadays, when you talk about like if you play chess, you know people talking about I'm like a 1400 chess player, 1600 chess player. It's their ELO rating, and ELO rating assume each player is represented by a Gaussian distribution, but it only tracks the mean of that Gaussian. So you're gonna basically everybody is gonna have a ELO rating. That's the bigger than that number is, the stronger you are. And other than ELO, for a lot of games that's later people also invented this Glico rating system. Actually, two versions. One is Glico 1 and Glico 2. And compared to ELO, it has like a rating, which is like a real number that's kind of like representing how strong you are. But it also consider explicitly the rating deviation, which it's like the Gaussian variance, but it's in Glico it's called RD, which is like explicitly measured. And also in the second version of Glico 2, it also added a volatility number, which is kind of like measure how fluctuated your play is. Like some players could be really, ceiling could be really high, but on some bad days just can play really badly. So that's kind of captured in the volatility. And at Tencent, we also have, based on our game's need, we also do some in-house variation to either use it just like tune these two, or sometimes even marry them together to better suit our game. So we have some rating system. And I want to just give you an example of what actually a rating system contains using the example of ELO. As I was saying, there was a pre-game prediction. There was a post-game adjustment. So pre-game, two players match up against each other. And then we assume they already have some ratings that were previously tracking, rating A and rating B. Their predicted win rate for player A that's going to win the game is going to be this EA, expected win rate. And similarly, player B is going to have his prediction. So if you're familiar with the form, basically you can see this is essentially familiar with like machine learning, like deep learning, those like the math of the deep learning. This is essentially a sigmoid function, except you have the division by 400. Except you are based on 10 instead of E. And other than that, it's basically a sigmoid function. And then the game is going to happen. One player is going to win, the other player is going to lose. And then you're just going to have the actual outcome of the game. Instead of EA, you're going to have SA and SB, which is 1 if player A wins, and 0 if player A lost. And if for SB, it's going to be 0, 1, right? So for ELO, the simple case is you're just going to each update each player's rating. So the player A's rating update is going to be RA equal new rating is going to be RA new, basically is going to be RA old plus some hyperparameter K here multiplied by the difference of your actual outcome and your prediction. And similar for RB. But this K is actually a step size, basically decides how aggressively you want to adjust your rating after seeing an outcome of one single game. And after that, basically this post-game adjustment, so I'm just putting a level up here, which means like we're adjusting the rating, but for the player who lost, he's gonna lose some rating, right? So that's ELO, Glico, and also some of our like in-house solutions. And but especially for ELO and Glico, they are designed for a 1v1 game originally, right? So those games are cool. We still make a bunch of 1v1 game. For example, this is an auto chess, auto battler type of game Tencent developed. But Tencent is more known for games that like goes beyond 1v1. For example, this is Honor of Kings, which is potentially one of the biggest like mobile game played in the world. And it's a MOBA type of game, which stands for Multiplayer Online Battle Arena. So it's a 5-player team against another 5-player team type of game. So that's 10 players. We also have, if you follow the trend of the online games in the last 5-6 years, you know there's a type of game called Battle Royale, which is, there can be like up to like 100 players dropped onto the same map. They're just fighting for themselves and free for all style. And then that's just essentially 100 teams with 1 player. And also we can have a mix, right? Lose, okay. We can have a mix. It could be like 25 teams of 4 players drop on the same path, the same map, doing similar, like doing the battle royale style of battle, right? So how are we going to handle that? Our strategy was just like there's multiple ways to like naturally extend it into this one single player, like 1v1 type of game into whatever setting we want. So there are different strategies. So one of the strategy is individual-based method where like, let's just use like the Honor of King example. So we have 5 players on each side. We can do just treat each player as an individual player. And when a team beats other team, for each player, we think about basically the instance as he beats each individual player of the other team. We get the adjustment, then we just like somehow aggregate them, either using min or some other aggregation functions, and then do the adjustment. So that's one way to go from single player to a multiplayer. The other way could be just like treating this as an entire team-based thing. So we aggregate each of the player as a team, which is like a virtual player. The same for the other team. And then their win or lose are between these 2 virtual players. And after the game, we kind of like adjust basis 2 virtual players rating, and then do the kind of adjustment, do the same adjustment back to each of the players. Or there could be a hybrid method. So for example, we still do the aggregated player into a 2 virtual players, but when we pass back the augmentation, the post-game adjustment to each individual player, it could be depending on the different like players rating gap between the player on your one single player with each other player on the other team, or it could depend on like that player's contribution in this game, right? So there are like different strategy we can do, but which one is better? So actually, when I talk about like there are different strategies, there are different rating systems we can choose. Even within each rating system, there could be like different hyperparameters we need to tune. So how do we optimize for that? So to basically say, so we need to optimize for it, like we need some like at least some metrics, right? So we need to see some number to see which one's higher, which one's lower, which is good, which is worse, right? So for this type of like optimization problems, our metrics, we usually use some metrics like this. So one is like a winning rate arrow, basically. Based on our rating system, we can do like win rate prediction, but in the actually game data, we can observe the actually win rate. So we compare them to and compare the arrow, the smaller the better, right? Similarly, for the actual player in the world actually playing the game, they have certain rankings that we can also compare with our in-game ratings, ranking of their ratings. So compared to the rank list, we can compare the similarity, which can also be a metric, just measure like how good our ranking system is capturing the player's skill. And the other thing that's very important are the convergence rate. Usually, when the players start to play our games, we know nothing about them, so we need to start them with certain default value, like say 0, or like for ELO, I forgot, it's like 1,000 or 1,200 or something like that. But then after we observe they play the game, winning or losing, we're just gonna adjust their rating, and hopefully we can get to their right place as fast as possible. So the convergence rate, like how long does it take to reach like a stable level, it could also be important. So now we have everything. We have parameters, we need to choose mode, we need to choose parameters, we need to choose different aggregation strategies, and we have a metric slope. So we can just run it, right? So in our case, next slide. I think does it work? Is it stuck or?
Stuck.
Okay. There we go.
Got it.
Okay. Oh, yeah, there we go. So after you're choosing first you need to have a game, right? So I think for this graph, it demonstrated what the experiment we did for like a free-for-all battle royale game. And you choose your different like rating system. I think here we compare ELO with Glico. And then we basically fix a certain hyperparameter and just let it run and observe all these 4 metrics we care about. And in this case, you probably see the Glico is probably performing better because its convergence seems to be a lot faster and better. In terms of the arrow, it's lower than ELO. And also in terms of the win rate prediction on the players, you probably can see the predicted win rate is lined up with the real win rate a lot better compared to ELO. Maybe for some extreme high or low win rate players, it's a little bit over-predicting or under-predicting, but overall it performs better. So as you can see, we can just choose whatever we want to use and then just print out all this report and for us to decide which one should we use, right? So we put everything together as a full package, and we name it MMBench, Matchmaking Benchmark. And we basically, as what I previously described, so we have match mode. We have just you need to choose, depends on your game. And for your rating system, there's a lot we can choose, actually. And then there are different evaluations. So once we choose that, we can just run everything and then print out all the dashboard we need to see. And I also want to add that there's actually two ways of using this package. One is we use like when the game is already live, like it's already launched or soft launch, we have actually real players' data. We're going to use the real game's records and use that push room to help us to monitor, to tell whether the matchmaking right now is like working well or not. Or a lot of time our package, our software is actually used before the game is launched, before the game is in players' hands. We just propose different settings of different setting of the matchmaking system, like the configuration, the modes, and hyperparameters. And then we have a separate match generator and player generator for us to run simulations to generate like the simulated matches for to create this like simulated game matches. And then we do the same thing, just pass them through our system and get all the report. And we can tune however we want. This usually is tremendous help for a lot of game designers to basically visualize how this matchmaking system is going to work once the game is live. Right? So, and also we have a publication for this package, for this type of, for this project, and if you're interested, you can check it out. And also we want to talk about is Databricks has been a very good tool when we are working on this project, because like we are collaborating with a lot of designers, as I was saying, like there's a lot of work to be done before the game is launched, and so to collaborate with them, first of all, Databricks provide a very collaborative environment. Everyone, we can add the same files or notebook files in the same space. And also, we kind of separate the certain files. There are like Python code, very complicated Python code, but there are also specifically for the designers, certain config file. Like you can literally just like read the JSON here, like what they want. They can go in there and just add it to however they want, and they can just run the code. And this can be very easy for even some of the game designers that are not necessarily tech savvy. So we found it like very helpful for us to collaborate with those people. Oh, sorry. And let's just take a step back, and I just described to you one particular application of like using data science in may just help optimizing for skill rating system. The MMBench is a package we created. But also, there's a lot of things we can be doing, we are actually doing. For example, we can be doing like more accurate assessment of a player or team skills based on additional data. Other than just rely on the rating system's prediction, there could be additional data we can use. For example, we have users, how long have you been playing this game? And what time do you typically play the game? And things like how long do you play this hero a lot? How your proficiency with certain hero, because that kind of matters in a lot of the mobile type of game. So we can use that information to improve the prediction. And we also usually have special rule for the new player experience, because these are players like just trying the game out. We really want to keep them. We are gonna try to give them a better experience compared to a lot of the more established player base. And for the game that's like for the mobile type of game, if you play those games, you kind of like know the team composition is really important. If you're like your you're starting a team that without a healer, you are probably going to lose. And then that's something we also part of the matchmaking system we're trying to optimize for. And also, this is like related to matchmaking system. Usually, as matchmaking system, it's not necessarily 100%, but most of for the matchmaking, your rating is not visible to the players. It's just like underlying, just kind of like helping make sure that we match player like fairly. But usually, player needs to see some number goes up, preferably, right? So they need to see their ranking or their league or their tier. Usually, those are something we also need to adjust based on the outcome of the game, and that's not necessarily like the matchmaking rating, because some players just probably not going to improve that fast, but they still want to see progression in their score. So we also help do some like simulation with like for the player-facing progression scores, so which is kind of it can be done in the same system. And of course, a lot of things are we are just reiterating them through A/B testing, and which is not trivial, as Zhenyu previously mentioned. To deal with this like interaction data, there's a lot of special consideration need to be taken, and Zhenyu already mentioned we have some good solution for them. Okay, and there's much more. So let's take another like zoom out and finally take one last look at of this like roadmap of player journey. And this is matchmaking. We talked a little bit about A/B testing, experimentation. We talked a little bit about social recommender, but there's still so much we can do and we are doing. And so hopefully this talk convinced you there's a lot of exciting and interesting project in the video game space as well, which is probably people not necessarily know. But we also want to say like our like very talented team across the world are basically by doing this type of data science project, adding a lot of value to the Tencent games. And we are leveraging Databricks, which is an amazing platform. With that, I'd like to thank you all for your attention, and Zhenyu and I are happy to take any of the questions.